Hello everyone, welcome to MESS e-learning channel. So in this lecture today we'll continue with the topic projection of lines. From the last lecture we know that how to locate a point according to the quadrant system and from which direction we should view and on which plane we get the image. In this lecture we'll do the same with the lines. So now as we know that if I have an object here, so let's say I keep a line, let's say A, B, which is parallel to this plane here on first quadrant. So this is my first quadrant. So if I keep a line AB here and let's say I am viewing it, or the direction of the observer is this side and the direction from the top view is from this part. So if I view from this side, I would get the parallel image of this line straight onto the vertical plane. But if you view the same point from this direction, I would get a point on this plane, that is on HP. This is our HP and this is our VP. So for the same example, let's say I take this line at an angle of, let's say, theta from this point, that is from any point, and this inclination is with HP. So this inclination is with HP. So now if I view it from the top, I would not be able to see what is the exact inclination, because from the top it would be this distance what we will see. But if I observe this image from the front, that is in the HP direction, now I would be able to see the angular inclination with the HP, that is the front, that is the horizontal plane. Let me demonstrate this to you. So let's say if I have this as the representation of the first quadrant here, and let's say I keep this line parallel to VP. So now when I keep this line parallel to VP, if I view it from the HP direction, I would get the vertical line, the image of this vertical line on VP. But from the top what I will be able to see is the point. I will be able to see a point on this part. So it would be like this is the line and this would be the point here, if I am viewing it like this. Because what we are doing, we are keeping this plane, this line from the front view, that is we are keeping this on HP, that is parallel to VP condition, and from the front if you view, you will get the straight line, that is the vertical line, and from the top it is the point that we see. Now if the same pen is parallel to HP, straight parallel to HP, so from the top you will be seeing a line which is this line, and from the front if you see it, if I am keeping it here, in the front if you see, you would see this point. From here if you see, it will be a point. So now the same example, what I do is I keep these at an inclination of some angle, let this be some angle with the HP. So now if I view it from the top, I won't be able to see what angle it is inclined at, so or what angle it is inclined to, HP. So let's say I have an inclination of theta here, and if I view it from the front, you would see the same inclination on the VP, but on the HP you would see a line. Now same, if I keep this plane, this object inclined to VP like this, if I keep this inclined to VP like this, now from the top if you see, you would see that inclination on HP, but from the front you would see a line which is the representation of this. So now from this what we conclude is, when we have a line which is inclined to HP, when we have a line which is inclined to HP, inclined to HP, we would get that, or we are able to see that inclination in VP. When a line is inclined to VP, we are able to see that inclination in HP. So this is very important. So whenever we have been asked about, or they have said or mentioned that there is a line which is inclined to HP, then we would draw the inclined image on VP. And if it is said that we have to draw a line which is inclined to VP, then we have to draw that inclination in HP. So now as this line is in first quadrant, so if this line is in first quadrant, I get from the front view, I get this as my front view on the vertical plane, and this point as my top view in the horizontal plane. So if I take a condition in the first quadrant that is parallel to VP, then what happens? I get the line which is parallel to VP so this is parallel to VP. So what I get is, I get this line in VP, that is the front view and the top view. As we know that in the first quadrant I have front view above XY and top view below XY, and here I'll get a point. Now if I have a line which is parallel to HP, so if I have a line which is parallel to HP, I would be able to see the line on HP, and I would be able to see a dot in VP. So I will be able to, now this is parallel like this, I am taking it like this. If you have to keep it like this also, it's fine, but I am taking it like this. So it would be like, this is the parallel line. If I keep it like this, it would be like this to the, and then when you rotate it to 90-degree clockwise direction, I would get this as vertical line. So this would be the line which is parallel to HP, and on the VP we would be able to see a point, because from here if you see, you would get this point. So the front view would be a point and the top view would be a line. These are the two conditions. When I have inclination, now we are talking all about first quadrant. So if I am talking about inclination with HP, so let's say a line is inclined at 30 degree to HP. So that line, the inclination is with HP, so I would be drawing it with VP. So this would be 30 degree, and on the top view I would be getting a line like this. If I have, which is inclined at 30 degree to HP, on the vertical plane you would be able to see this, but on the horizontal plane it is a line parallel to this plane, and if you tilt it, I would get a line which is at some inclination, that would be that we have to find. Now similarly in case of angle inclination to VP, so let us directly move on to an example. So let's say I have a line whose total length, this is the line AB, and so I'll write line AB. The total length is 100 mm. It is inclined to HP at an angle of 30 degree and inclined to VP at an angle of 45 degrees. Now location of this point, that is point A, is given to us. So it is said that point A is 10 mm above HP and 20 mm in front of VP. So by this information, what we know is, if a line is above HP and in front of VP, that point lies in first quadrant. So while we start to draw, first of all what we do is, I'll draw my reference line, that is a XY line here. After that, now I have the information about point A. This is the information about point A. So this is above HP, so this would be visible in VP, and this is in front of VP, so this would be visible in HP. How is, if a point is lying 10 mm above HP, so there is a point here above HP, so it will be from the direction of HP, and you would get that point on VP. And a point which is 10 mm in front of VP, from the direction of VP, if you observe, you would see that point on the horizontal plane. So similarly, what I'll do is, I'll draw a 10 mm at a distance of 10 mm, I'll mark a point, this is 10, and this would be the front view of A. And at a distance of 20 mm, I'll write this is 20 mm. At this point, I'll be having the top view of the point A, that is A. So what we do is, we represent the front view with A dash, and we represent the top view with A. So these are two locuses with respect to A dash and A. Let me name this as locus of A dash, and this would be locus of A. This is not compulsory to write, but it is easier to understand like this. So now what it is said is, this line is inclined at an angle of 30 degree to HP. So I already said, if a line is inclined to HP, the inclination would be visible to you in the VP. So now this is my VP, that is the vertical plane, and this is my HP, that is the horizontal plane. So what I'll do is, I'll draw a line that is 30 degree inclined, 30 degree inclined to HP in VP. And next part is, I have a 45 degree line inclined to VP, that would be opposite, that is visible to us on VP. So this is 45 and this is 30 degrees. Now once I have these two inclination, I know the actual length of the line, and these are the actual inclinations of the line. So this we call it as true inclinations, and this is called as the true length. I'll write this as true length, and these are true inclinations. So on the true length, I'll mark my true inclination, that is 100, and once you get the point, you draw a locus. This would be locus of B dash, because this is A dash, so the line would be A dash B dash, and this is A, so the line would be AB. So this is locus of B. Now once I have these two lines, now we have a procedure to follow. And always remember that A dash and A should be collinear to each other, that is on the same vertical line. So once you have the true lengths marked, what we do is, we have a procedure, that is, if I have true length in the front view, I drop that to get true length in the front view, I drop that to get my plan length, and I rotate that to get my top view. This is plan length and this is top view. Similarly, if I have true length in the top view, I would drop that to get my elevation length, and I would rotate this to get my front view. Now elevation and plan is like, if I have an object in the top view, if I am observing an object in the top view, that is called as a plan of that object. and if you are observing that image from the front view, that is the elevation of that object. So let's say I have a circle of some radius r, and I rotate this to get this distance, which will also be equal to r. So here also what we are doing is we are taking the plan length and we are rotating to get my top view. That means both of their measurements should be same. Here the elevation length which we have, we are rotating it to get my front view. Either you rotate from the elevation length to the front view, or from the front view you rotate it to the elevation length. Both of their length should be same. So they actually mean the same thing, but we have a procedure by which we get two different points. So now I'll follow this and we'll solve the problem. So I have true length and this is my front view as we are solving for the first quadrant. So this is my front view and this is my true length. So from the true length of the front view, if I drop it, I would get my plan length. Now always remember that the plan length is giving us the top view. That means the plan length would be in the top view and this is the top view. So I have to drop this till the locus of A. Now what is the next step? Once I get the plan length, I would rotate it to get my top view. So what I do is I take A and this distance, so I'll name them first. This is A dash, this is B1 dash, and this point would be B1, from B1 dash to B1. So once I have this point from A and B1 as my radius, I would rotate this to get a point which will be my top view. I'll join them and I would get this as B, which is my top view. We have completed this. Now we would move on to this point. So let's say I have true length of top view, which is this. I would drop it to get my elevation length. Now elevation length is always in the front view. So what I'll do is I'll take this line and I drop it till the front view. This is my front view, so we have to drop a true length of top view till the locus of A dash. And once I have this point, so this point is always denoted by B2. So let's say I have this from B2 to I would get B2 dash. From A dash and B2 dash, I'll take A dash B2 dash in my compass as a radius and I would rotate this to get my front view. So this is A dash and this would be B dash. So now one thing what we have to see is this B dash and B should be in the same line. That means they should be collinear to each other. And this distance that is between A and A dash line and B dash and B line is called as DBEP. That is distance between end projectors. I'll write it here. DBEP is distance between end projectors. Now this angle with true length in the front view is the inclination with HP, which is called as theta, and this angle of true length in the top view, that is inclination with VP, is called as phi. This length over here, this length here is the plan length and this length here is the elevation length. I'll just mark the arrows. Is the elevation length. Now this is my true length, which will be same in the front view as well as the top view because the actual length of the line will remain same. This is the front view and this is the top view. These are the points for elevation and plan length. And now one other angle that we have is this angle. This angle is alpha and this angle is beta. So now if we have alpha and beta, and if I have to give you information about alpha and beta, our alpha is the inclination for front view in xy plane and beta is the inclination of top view in xy plane. So if I have to give information about alpha, it would be that the top view of a line is inclined at an angle of some angle, let's say 55 degrees with respect to xy plane, or a top view of a line is inclined at an angle of 60 with respect to xy plane. So whenever an angle is inclined with respect to xy plane, either it would be alpha or beta. And if it is mentioned that angle is inclined at with respect to xy plane for top view, then it would be beta, and if it is for front view, it would be alpha. Like this, we have in total 9 informations. So let's say what are they? So we'll have true length of the line, we'll have front view, top view, plan length, elevation length, theta, phi, alpha and beta. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Except for all these, we may have a data of D, B, E, P. So either of them, from out of these all 10 datas, if we have 5 compulsory datas, then we can solve a question. Thank you. Hope you understood.